Hello, here in this video we're going to be looking at the product rule in terms of our rules of exponents. So we'll go ahead and start here. So what the product rule tells us is when I have the same base, and keep in mind the base is always the number down low when we're looking at exponents, and I'm multiplying, I will add the exponents. And remember that regular numbers still multiply like normal. So here's our first example. So what I'm checking for is, do I have the same base? And I have an x as my base here, and I have an x as my base here. So what that's telling us is when I have the same base and I'm multiplying, as we can see by the parentheses here, these two terms are multiplying, that means we're going to add their exponents. So our answer for this will just be an x to the 7th power. Now I know we've looked at this a couple times in class, but here's how this rule works. We know that when we see x to the 3rd power here, that's really an x times an x times an x. X to the 4th power is 4x's. So we have x times x times x and times x. So if I'm looking at the total number of x's that we have multiplying here, I see that that is where our 7 comes from. Alright, so that's a pretty basic example of the product rule there. Alright, so this one's going to be the same concept, except we're throwing in some normal numbers here for us. And now keep in mind, we like to put our normal numbers first, and then go in alphabetical order. So we'll start off here. We see a 2 and a 4. And keep in mind, we are just multiplying here. That's what these parentheses tell us. So when I do 2 times 4, we get an 8. Right? Normal numbers still multiply like normal. Right? Then I go to look at my base. I've got a base of y here. I've got a base of y here. So y to the 5th power and y to the 3rd power, with the product rule, I have the same base, I'm multiplying, so I add my exponents, get a y to the 8th power. And that would be our final answer for this. Okay? So for this last one here, also going to throw in a negative exponent here so we can see all the different types of situations. So when I start off, keep in mind we always use our normal numbers first. So I'll look at this 5 and the 6. And I know that 5 times 6, because normal numbers multiply like normal, give us a 30. Alright, then I'll go in just alphabetical order. That way everybody has their answer phrased in the same way. So we have an x, and we have an x to the 5th. Now keep in mind, anytime we see a variable or a base, or whatever it is, without an exponent, we know that there's really an invisible 1 with it. So when I go to add these two terms, we have x to the 1st power, x to the 5th power. With the product rule, I'll add the exponents and get an x to the 6th power. Okay, so when we look at the last piece here, I'm looking at my same basis of y. Got a y to the 3rd, y to the negative 5. So when I add these, do my 3 plus a negative 5, we get a negative 2 as our y exponent. Okay, so we cannot leave our answer here in this form because it's not all the way simplified. We have a negative exponent. Now keep in mind, negative exponents tell us to take that base, and only the base that the negative exponent's with, and it has to take the reciprocal, which means switch spots in the fraction, and when it gets down to the denominator, it turns positive. So we'll note that nothing has told our 30 to move, nothing has told our x to the 6th power to move, but because of that negative exponent, the y in the squared 2nd power will move down to the bottom and become positive. And that was because of the negative exponent. So this here would be our final answer. Alright, so as a quick reminder, normal numbers multiply just like they always used to. With the product rule, when we have the same base, we add our exponents. And any negative exponents still work the same way as always. They will switch spots in the fraction and become positive.